the forces that we're most interested in is lift, drag, and turning. This is Mr. Raleigh's equation for forces on an airplane. The equation predicts the force acting on an airplane. Two parts of the equation is constant and the density of air. The next part of the equation is the area. The area is perpendicular to the direction of the plane. C is the drag coefficient. And V is the velocity of the plane, and that's how fast it's going. And there's a very important part of the equation, and that is V is squared. Force is not linear with velocity. And that means twice as fast, 4 times the force. Mr. Raleigh was knighted for this equation. So we're going to use this equation to test where we can get our ball. Our neuron plane has a very small front area. Small a means small left for drag, but our area for lift is large. Big A for lift, large force. This means that our neuron can float and fly slowly. Means that it can also fly fast. When you combine our large area and high velocity, then we get a large turning force. On a pressure bubble. This bubble can be predicted by Lord Raleigh's equation. So we use Lord Raleigh's equation to fly the bubble. Two things that we can easily control in Lord Raleigh's equation is area and velocity. Area in Lord Raleigh's equation is in the direction of motion. If the plane was coming at you, that would be scary. If we were just working with the area, we would use these sizes of bubbles. Little bubble is 0 alpha. The big bubble is like a lot of alpha, like 90 degrees alpha, and like this. When we're flying, we're always thinking about where our bubble is. For our bubble, we're constantly integrating area and velocity. Here's a clip that shows an example of this. So then we lift the nose up to expose more area. Neuron is coming in really fast. More area means more force, and then the plane stops. We lift it up, forward. Once the plane is going fast enough, these square kicks in and the plane can fly upwards and forwards and all those thingamabobs. Horizontal, I might have the bubble like this. If I start to roll, I might have a bubble like this. If I roll 90 degrees and I'm not centrifugally accelerating, my bubble can turn like this. With no bubble holding the plane up, it will fall right out of the sky and straight down. Here's an example of one of my dad's crashes when he lost the bubble.
Oh!
Bubble, bubble. The bubble represents pressure gradient. One area you control is the area in the equation. A is for area. We see this on jet like a ring like polka dot. The other rounds of the jet are out here when they have the most torque. These are the spoilers on the jet, and there's 3 more areas more than the aileron. When the plane is landing and reducing its velocity, when landing, the pilot will use the spoilers like ailerons. You can call them spoilerons. By using the spoilerons, we add area to our large equation. As the velocity went down, the spoilers increased the force. If this was the size of the bubble on your ailerons when it was landing, by using the spoilerons, we increase the bubble to this size. That's giving us more force outside of the wing. Torque is equal to R times S sine theta. The torque from the spoilerons and the ailerons can roll the plane when it's landing. Bubble comes in the planes and you design the planes as well. When you look at the model, you're going to say, where did I get my bubble? Bubble represents the force that will act on the airplane. If we were interested in building this Grand Cup, he would have a lot of forward motion area. He has a very little lift area for horizontal lift. Little! Thinking of the bubble, this plane would be hard to build. This is my night dragon. She has very little forward motion area in the front, so she will have a little bubble. She has a lot of lift area for a lift bubble. She also has a little lift area bubble to pitch the plane. And thinking of this bubble, we can build this plane! The airfoil was so inspiring to us that we took this toy and transferred it into Night Theory! And make this our flying Night Theory! This plane was a lot of fun to think about and build.
bubble. George Bach said, all models are wrong, but some models are useful. The bubble model of building and flying is a simplification, but it's useful. George Bach wrote the book of Bach's Hunter and Hunter. This book was called Design of Experiments. It's partly in what's our name. We are RCDOX. That stands for Radio Control Design of Experiment. All models are wrong, some models are useful. We may be wrong of a lot of that we think we know, but we're out having fun. We're learning about flying and aviation. We think flying and flight is beautiful. To see a plane flying is amazing. It's awesome to design it and build it yourself, and then see it fly in the sky. We use our bubble theory and Lord-Rayleigh's equation to apply the forces necessary to fly the airplane. We don't think that it's an accident that angels have wings. When generations have thought about flying, they thought it was beautiful. So that's why they gave angels wings. Go find the bubble and have fun!
Left.